Time zones, UTC, and the one rule every developer should know. Store UTC, render local. This is L6 of the time stack, the human layer. Time is a stack, not a number. Down at L3, we agreed on the epoch. At L5, we traced it to an atomic reference. Up here at L6, we just draw that number for humans. At 1:30 in the morning, this job ran, then ran again at 1:30. Same job, same wall clock time, twice in one night. It's the classic DST bug. The machine wasn't confused, the code was. Let's see why. Underneath everything, the machine keeps exactly one number, UTC. The count of seconds we agreed on, traced to an atomic clock. That number never forks. Everything in this video is about how we draw it for a human. But nobody reads a UTC instant. People read a local wall clock, a time and a place. So we have to convert the one number into the reading they expect. Here's the whole layer in one picture. One number in the middle, many wall clocks around it. Same instant, many readings. The arrows are the only thing doing work. So what's actually on an arrow? Part 1 of a time zone is just an offset, a number of hours and minutes added to UTC. India is UTC plus 5 hours 30. Add the offset, get the local reading. If that were the whole story, this video would be over. But the offset is not fixed. Part 2 of a time zone is a political rule set, when daylight saving starts and ends, whether it applies at all. New York is UTC minus 5 in winter, minus 4 in summer. The offset moved, the UTC number never did. Where do all these rule sets live? In one shared file the whole computing world relies on, the IANA time zone database. It records every zone, its current offset, and its entire history of changes, because laws change. It's updated several times a year. Always name a zone by its IANA identifier, area/city, like America/New York. Never by an abbreviation. EST can't tell you when daylight saving starts, and worse, abbreviations aren't even unique worldwide. The ID carries the rules, the abbreviation throws them away. When daylight saving begins, the clock springs forward, and an entire local hour vanishes. In New York that night, 2:30 a.m., simply never happens. Ask your system to schedule something for 2:30 local, and you've asked for a moment that doesn't exist. When daylight saving ends, the clock falls back, and a local hour repeats. 1:30 a.m. happens twice, 60 minutes apart. Run at 1:30 local is now a question, not an instant. Which 1:30? That ambiguity is exactly why our cron job fired twice. The wall clock lied, the number never did. Here's the fix, and it's almost boring. Store the job's time as UTC. There's only one of 5:30 UTC that night. No gap, no repeat, so it fires once. The ambiguity was never in the number. We created it by storing a wall clock instead of an instant. Here's the one rule this whole layer earns you. Store UTC, render local. Keep UTC everywhere it matters. Your database, your logic, your logs, the wire between services. Convert to a local wall clock at the very last step, the edge, purely so a human can read it. Two things I deliberately glossed over. First, that UTC number occasionally gains a strange extra second, a leap second. Second, UTC is not the same as TAI, GPS time, or GMT. People mix those up constantly, and one of them isn't even a standard. Both get their own episode next. A wall clock is a view. The number at the center never moved. Only the rendering did. Store UTC. Render local. Next, the leap second in UTC versus TAI versus GPS versus GMT. Time is a stack, not a number.